Hello, my dear friends. In the last part, we left off here. We had successfully implemented the turn-based system, and we saw basis of bot movement. So for now, I have turned off that function, and we would write the automation from scratch. So let me show you where we are right now. So here we can make manually, we can move all different houses. So it's a green stand. We cannot click on any other button, and we have to click on the screen. And whatever the role it is, we have to manually make it move. So this is showing correctly. We are getting the correct turn rotation, but we need to automate this, and we also need to give import some functionality. So let me quickly go to coding. Let's get here. Okay, so this is the same the point where we left off in the last video, and I would just like to highlight that I have made small changes. First of all, in check for hit function, I have reduced the time because it was taking too much time to actually register the hit. So I have reduced that time to 200 milliseconds. And even if we want to unlock, then the same goes for that. We've also reduced the time to 200 milliseconds. And rest everything is same. So from here, first of all, we would now make our we write this make next time. So we would make write this function. So let me quickly add this function. So first of all, we would have this definition. Let's define this function here. So this is the structure for our make next time function. So this async code block, this makes the function run asynchronously. Asynchronous means that um, we are not executing it in sequence. We will just call this function, and then we would go back to our other routine, and we would perform other tasks, and this function would run in background. So we are making this function run in background because whenever the bots are moving, it becomes automatic. So we don't want it to consume the time or resources for other tasks. So we are running this on in the background. And the structure is very simple. We have to make this variable turn isn't finished. So whenever there is a bot turn, we have to define this variable. But first of all, initially, this will be false. There is no turn, so turn will be finished. Based on this variable, we will control different aspects of our gameplay. So basically, whenever we start, we would roll the dice, and whenever we start, we would set this to be true. Whenever we are in this function, we would set this to be true. And when we are done, suppose this is the part where we are done on some condition. We are done with this time. So at that point, we would set this to be false. So this is going to be our structure. And while because these are bots, and it can totally happen that while there is one bot's turn, another bot comes and tries to make the turn. So in that case, we can guard against it. We would just say its turn isn't finished, then simply done. We don't need to make any function for. So we don't need to execute this function in case of that. So this would guard against the unnecessary turns, and also we need to add one more function because we are going to get so many turns from the parts, and during this time, when we are executing a turn, we need to wait for a certain amount of time. So we can write this utility function basically. This function, what this function does is, it simply waits for a certain amount of milliseconds. If you provide give some milliseconds, it will just halt the execution and wait for that time to execute. So in our background, when we roll a dice, we need to wait for a certain time. Our roll dice function, and let me show that to you. So here we have this function. So it takes about 1 second to make the roll. We have set our animation in such that it waits for 1 second for the animation of dice rolls to finish, and then it determines the correct dice. So we have to wait for that. And similarly, when we make a move, let me show that function. When we move token, then each step consumes 120 milliseconds. So this is our waiting time. So we consume 120 milliseconds for each and multiply that by our whatever role we have, and some additional time in milliseconds. So that our movements take a reasonable amount of time, and they are not so fast and not so too slow as well. So in order to accommodate those, and also whenever we set variables, we have to wait for certain time to execute that function, because we are automating everything. So this is a function that we have to write. And also we need one more variable, bonus. Whenever we hit any bonus, we call a function which is our add dice roll. Suppose on double sixes, we call this function add dice roll. So we would go there, and we need to tell our bots that they have unlocked a bonus. So for that, we will use this variable, bonus is equal to true. Whenever there is a dice roll, we need to tell that bonus is equal to true. And similarly, whenever if we consume a dice, it means this function is only called where if we don't get two sixes on the roll. So if we don't get two sixes, then we need to tell that bonus is equal to false. So there is no bonus. So this is the second only change we need to do in our old functions. Rest we have set. Uh, okay, in this roll two dice, we don't need to do any change. Okay, so now we would write our function, and we have the bonus we have done isn't finished, and so let's write this function. So basically, here when we enter this function, we make turn isn't finished is equal to true, and then we would need to we also need to have okay, so we need to know that we need to set some things. Let me quickly set some things. Okay, so first of all, we have to wait for about 500 milliseconds or half a second so that GUI is properly adjusted to the new turn. And if it's red's turn, it means it's a player. So we would just return. We would just simply say turn isn't finished is equal to false. So our turn won't be finished. And also, we don't need this button variable here. So we would start from turn isn't finished. We would set it true, and then we would wait another. We would wait slightly so that these variables are properly set. Then we would come to our while loop. This while loop will run till the turn is not finished. So we would write this. Let me add the definition. So So when we roll a dice, we have to have this. For example, whenever we start a turn, we have to roll a dice and we have to pass the house, whichever house it is. Then we have to wait for 1 second. To be safe, we add 200 milliseconds on top of it. Then we would call determine can move function, which just determines which tokens can move or not. So we would call this function and we would wait for 500 milliseconds to execute that function. Then we would check if there is bonus. This is pre-move bonus. We have two types of bonuses. One is pre-move bonus, which is two sixes once. So if there are two sixes, then even before making a move, we would give additional dice roll, and we have to roll the dice again. So for that, we would just wait for 300 milliseconds, a grace period to set every variable properly. Then we would set bonus false. We can skip this as well, but we have to set this false to be safe, so that it doesn't soft locks itself. And then this statement continue, it means that skip everything and execute this loop once again. So it would come here and it would just roll another two dice and get the roll. Okay, so when we roll the dice, now we would enter the second loop. This loop will keep on running until all the we have rolled the dice. So this inner loop would just make the moves. It would consider the top roll and move the tokens based on some logic. So let's implement that. In the inner loop, we just need to assign the roles, and then we would make necessary movements. So first of all, we would have a variable called role, and this would be just the current role. Then we have to write a select random bot function. This function would make sure that our bots, how our bots, which bots are being selected for movement, and we would update this function to give personalities to bots as well. When the token is selected, then we would also see there can be a case that there is no token which can move. So our selected token can be null. So we have to break this loop. It means that we cannot move. And if this is not the case, then we must have some token. Then we would get its index and we would pass it to the select token function, which would make it move. Let me quickly show this function. So here this function, we just select the current token, and we would check that it, it it is a correct token and its turn. It is actually the token whose turn it is, and then we move this token. So this is very simple. Let's get back. So here, when we select the token, we then whenever the token is selected and it start moving, then we would automatically get to move the steps which are on the current roll. So we have to wait. We are just increasing the wait time from 150 milliseconds per roll and adding additional 500 milliseconds, so that we are 100% sure that this token has moved correctly. And if we see that our current rows are empty and we don't have any more current rows, then we need to break this. So this loop would make sure that whatever let me show the interface. So whenever we roll, we can see that we have rolled the dice and these are our rolls. So till these rolls are finished, the inner loop would keep on executing. So let's get back. So this would make sure that we have correct implement correctly. We have the movement nailed down correctly. And when we also need to check for post turn bonuses as well. There are pre-move move bonuses, which are two sixes bonus, and the post move bonuses are basically hits. Either it's a hit bonus or we might it's a finish bonus. So the token has finished its journey. These two bonuses would be determined after the turn. So we need to accommodate for that. So we would just check that. We would see if the tokens the rows are empty, then we would say wait for a small grace period, and we would check this bonus if we have a bonus, and this would be post move bonus. Like if we have hit something, or if we have finished our a token's journey, then it would do the same. And if there is a bonus, then it would continue and execute the outer loop once more, and it would continue to roll and get next rolls, and then do those rolls would be executed. So, and after it is done, it will simply set this turn isn't finished to false, and then it will call skip dice. So skip dice would make sure that dice is properly skipped. And we also need to add one more check here, because we need to make sure that if turn isn't finished. So if turn isn't finished is false, only then we need to make this move. If turn is in progress, then we cannot make this move. So we have to add this condition, and also here this skip dice is extra. We only need to skip the dice if the player is red. Otherwise, we don't need to call this skip dice because it would unnecessarily skip the dices, and the bots would skip their rolls. So we have to make sure that we add this. So we would just last house. If last house equals to red, only then we need to call this skip dice. Uh, so with this, our setup is complete, and we just have to write this function, which is select random bot. So let's quickly write this function. So this is going to be a very simple function. Let me quickly add this function. So we would simply in this function, we would check our current house tokens, whichever token we have. Then we would filter them based on movable tokens, which tokens can actually move. So if there is no token which can move, then we would return null, which means empty. And if there is only one token that is movable, then we would simply return that token. Otherwise, we would just return any of the tokens which can move. So this is a very simple logic for select random bot token. We would just this last function. This takes whatever tokens there are, and selects a random token amongst the movable token and returns that. So if we save this, and let's try to check if this works. So let's get back to our browser, and let's refresh. And okay, let's make a turn. So we have rolled out the 6. So we can see that the bots are getting their turns, and they roll their dice automatically. And whenever they get a roll, they automatically execute their turns. So this is the behavior that we wanted. So let me pause and let's resume when we have some interesting movement. Let's see if bots can figure out their bonuses correctly. So we can see that bots are behaving as expected. And let's try to capture if there is a bonus. So there is a probability that yellow might get to hit this token. So let's see. So it has hit the token, and it has executed its bonus correctly. So we have seen that, and we have also seen the pre-move bonus as well. We just got 2 6s, and it has executed the roll correctly. So basically, this we our bots are some behaving as expected. So now let's get back, and let's give them some intelligence, or give them some personalities. So basically, our whole structure, it is set. We don't need to make any more changes in the structure. Make structure is good. Uh, we just need to make some changes here. So basically, let me quickly update this function. So in this select random bot token, our initial half of the function will be same. So in case there is no movable token, or there is only one movable token, we don't have any choice. We have to do this process. We have to return a null and or maybe return the only token which can move. But after that, we can implement some logic. We can give personalities to bots. So as we know that our bots have profiles, in the last video I mentioned that green bot would be pacifist bot, yellow bot would be aggressive bot, and blue bot would be a smart bot. So we also have one more parameter, which is each house needs to at least hit one of the token, opposite houses token. So in order to unlock the final home. So basically, before their dominant behaviors, they would be out for blood and would want to hit any other opposing bot, so that any opposing token, so that they are able to enter their houses and unlock their locks. So we would this is our structure. We would need to write these functions: move peacefully, move towards it, or move smartly. So before we write these functions, we have to have some helper functions. So basically, we need two helper functions. We need to determine the board distance from each token. So this is a very simple function. This gets two inputs, and it just determines the correct distance on the board. So as we know that we have our path loop, whose length is 52, and we have to just mod it by path loop length and tell if one token is how many board units away from other token. And the second one is get hittable enemies, because this is a utility function. We have to know that uh, if which animals can be hit. So basically, first of all, we need to get the index. So we have a token and we have a role. So we get our token's current path index plus role, and we would just mod it by the path to blend. So we get the target index. So that target index should be where we would know that if we can hit any other token or not. Then we would just filter our tokens. We would filter, first of all, we would make sure that the tokens are not of the same house, and token are not inside the final steps. The same checks that we have also implemented in our hit check for hit. And we also need to know that these are not included in the safe zones, so we cannot hit the safe zone tokens. And then we would just make sure that our whatever the tokens path index is our target index. So if any of these matches, then those tokens are hittable tokens. So we would need this utility function to implement correct behavior of the bots. So first of all, we would just implement move towards hit function. So let me quickly add that and let me explain that to you. So this one is for yellow. So move towards hit function. In this function, we basically, whenever we are trying to implement a bot behavior, we mostly use scores to motivate the bots to achieve the best score. So first of all, our score is negative. So we just start from arbitrarily low score. And our best token is also null. We don't have any selected any best token. So we are getting our movable tokens. So whenever we get our movable tokens, we pass them to this function. And for each token, this loop would run and it would determine the score. So it would initialize the score from 0. and then we would give some rewards. So if we get hittable enemies and we see that their length is greater than 0, these hittable enemies would return all the tokens which fulfill the criteria which can be hit from current token. So for any hittable tokens, we would increase the score by 10, by 100. So it would motivate the bots to hit. Then there is also a reward. If we cannot get any hittable enemies, then we must be, if we get near to the enemy, then that would also motivate, increase the score. So basically, we have set this distance to be 50, and this is just an close to the path of lens. So enemy can be very far from us. We just need to know that we get the enemy tokens, and we make sure that the house is not the same, and the enemy's token is not inside the final steps. So whatever the remaining tokens, we just calculate the distance from them, and if the distance is less than nearest enemy distance, which we started arbitrarily at 50, then we just calculate the lowest distance. So when whichever is the lowest distance, we just increase the score, and we subtract this from 50. So this would motivate this token to move towards the enemy tokens and reduce its distance. First of all, it would try to hit them. Otherwise, it would try to get close to them. Then we would just simply we would assign the score. We would check if the score is better than the last score, the current best score, and we would just update the score and token. So after this loop has been done, we would get the token which has the most probability of hitting the other token or getting close to the other token. So this is for aggressive yellow bot. So let's add the pacifist bots routine. So how would it behave? So basically, we are using the metric, which is score-based metric. In our cases, we would motivate the bots to move towards the houses based on this. This is also very similar, but we also need to know that we must hit. So first of all, we would determine if this hit parameter is satisfied or not. We have to move peacefully, but we must at least hit once. So for that, we just get this status. We already have log status for houses. Let me show that. So we made this status to determine the logs. So we are using this to move peacefully. So similarly, we would initialize the best token to be null and best score to be negative. Then similarly, we would initialize our score, and we would get hittable enemies. So we would just determine here that if any currently uh, is there any enemy which could be hit. If we can hit any enemy, then we would only hit if we have this condition we must hit. If we don't want to hit, then we would not hit any enemy. So we would, if this is the case that it is the first time and this particular house hasn't hit any token, green hasn't hit any token, then we must give it incentive to hit at least one token. So we would just increase its score by 10, by 100. Otherwise, if it tries to hit any token, its score would actually decrease by 100. Anyway, if this is not the case, if there is no hits, then only we would just give it 20 score, and then it would always prefer the safety. It would try to move away from the threats. So we would just determine the distances, and we would just try to avoid the opposing tokens, and we would just update the scores based on each iteration. We would at the end of this the we would get the token which can move away far from the other tokens. So we would see this in action as well. And also now the third one, which is move smartly. So this bot would have some smart moves. So let me quickly add that function as well. So for this bot, let's add this function. So basically, our goal is, as we stated, that the smart bot would try to always finish all of its tokens, and it would get them to um, it would try to finish its tokens before every other house, and its goal is basically uh, its house entry position and plus six, which is basically the final. We know that each house entry position is based on the where one token can enter the final house if it is unlocked. So if we add 6 to 8, it means that this is the finishing place. This smart board always aims for the finishing place. And so its goal is to reach there. Then it would just simply initialize the best token to be null and best score is negative. So it would first of all always prioritize finishing. So it would try to minimize its distance towards the goal. And if we have hittable enemies, it would try to hit because it's a smart board, and also it would try to always be in the safe zones. So it gets incentivized to be in the safe zones. And similarly, the final score would be updated, and we would get the board which would make smart moves. So with these, we can let's get back to our browser and let's see if we are able to if we have been able to give some proper behavior to the bots. So let's see. So in the first time we have rolled out 2 6s. So we are getting lucky. So let's see what how bots behave. So this is the aggressive bot. Yellow is supposed to be an aggressive bot, and blue is supposed to be a smart bot. So let's see how they behave with time. So as we can see that as a consequence of its aggressive routine, uh, yellow is behaving smartly. But as we can see that blue is a smart bot, so it didn't take out its tokens, and it's just moving one token, and it's has executed correctly. It has hit, and it has also consumed the bonus. So far, our bots are behaving correctly. So, okay, we have an opportunity to hit this token. So let's grab this opportunity. So, so we have got a bonus, and we have also unlocked our bot. So let's see how this works. Okay, now we can see that Pacifist bot is out. So we can see that yellow is behaving very smart. It is capitalizing its tokens, and it's only moving one token at a time. So, okay, so we are safe for now. And we can see that green is a pacifist bot, so it is trying to move only one token at once. So as you can see that yellow is trying to sandwich me. Let's see if we get some lucky rolls. Okay, we don't have any rolls. So let's see how yellow behaves. It might get some hits on us or on green. So first of all, it has uh, it has calculated that it can hit green, so that's why it has done this. And it couldn't hit me, so but it got closer to me. So this is some kind of intelligent behavior. So as you can see, blue just got lucky and hit me. So it is running away. So we can see that there is the beginning of some intelligence in these bots. And let's see if we get an interesting situation. So we can see that blue is not trying to get other tokens out. It is prioritizing the movements for only one token. So it's a very smart bot. And for yellow, let's see how it behaves. So it is trying to get close to the target. And we can see that blue is trying to run away and make smart moves. So currently, red board and red player and green board are at home. So we can see that yellow has correctly calculated and hit the token, and whenever it can, it would hit. So this is the correct behavior that we predicted for yellow. We programmed for yellow. So this is it for this video. And this concludes our Ludo series. We have been able to create a Ludo board first of all. Then we created these tokens, and then we implemented the movements. First, we implemented the turn-based rotations. Then we implemented automatic board behavior, and then we have finally implemented some personalities to the boards. So this was big undertaking. Basically, I underestimated the effort in creating a nice Ludo, which is playable and which offers nice playability. So all the source files would be given in the GitHub repository. Please feel free to use them, and also try to modify this code and make your own Ludo. And please give me your feedback. And if you like this kind of content, please like and subscribe, and stay tuned. In some time we would be back, and we would be back with some new series. And thank you so much, and take care.